This video is about horizontal asymptote. Horizontal asymptote is it's more of a guideline than the vertical asymptote. Vertical asymptote is absolute because vertical asymptote has something to do with the denominator. Whenever the denominator is 0 is bad, right? So, but for the horizontal asymptote, it's talking about what happens if you look at the graph, for example, like this. What will this line approach when x gets really, really large or when x gets really, really small? Okay? All right, now, how do we find vertical asymptote? Horizontal asymptote. It's easier than you think, but let's go over the 3 scenarios where it could happen. Okay, the first scenario, let's do. I'll do XY chart for all of these, and then we will look at the scenarios in a more analytical way. Let's take a look at this graph. Let's do XY. Okay, if you plug in a regular number like 0 or something, you will get 0. Right? We don't care about that because we are talking about horizontal asymptote. We wanted to find out what will this picture look like when x is really, 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 really big. Okay? All right, now, take a look at this picture. If x is, a billion, 1, 2, 3, a million's big enough. Okay? All right, now, think about what this number will roughly approach towards. Now, this is 3 million, and then at the bottom is 1 million minus 3. So you have a number at the top that is almost 3 million, and then at the bottom you have at the top you have exactly 3 million, and at the bottom you have a number that is very close to 1 million. Everyone can do the math that is like almost, right? You don't need to do it exactly, just do it almost. So for example, 500 divided by 99.99, everyone can know that, oh, okay, that's almost 100, so let's just do 100. If I don't ask you for the exact number, then why would you? You can just sound smart. It's about 5. You can sound really smart to a lot of people that are not, they don't know math, right? So if you do this, it's roughly going to be 3, right? It's exactly 3 million, almost 1 million. Now, if you take a look at that negative 1 million, we're going to look towards on the left side of the graph. So its top is negative 3 million. Now at the bottom you have negative 1 million minus 3. That is still almost negative 1 million. So 3 million, negative 3 million divided by almost negative 1 million, that is still 3. So now what do you notice? So when x gets really big, when x gets really small, it all approaches 3. So don't you think that 3 has some sort of significance? And then it does, because that will be the y asymptote. Goes 3. Same logic I want you to apply here. Okay. This time, I want you to use the similar logic. Let's just plug in x equals to 1 million. 3 times 1 million square divided by 5 times 1 million to the 4th power. 1 million to the 4th power is a lot of freaking zeros. Okay? So, how do I talk about this? Okay, let's take a look at this number. Before we even talk about this, let's talk about 100 square divided by 100 to the 4th power. Okay, so if you do your math, it's going to be 0, 0 divided by 0, 0, 0, 0. No. And then 0, 0. Right? So this number is going to be cancel. It's going to be 1 over 10,000. That is very close to 0. 0. Right? That's like 0.00 0, 1. That is kind of like 0 to me, if you simplify that. What I'm trying to say is that if the denominator has a larger numerical value in the exponent, if you have a large number, it will cancel it out, like the top one. And then this number will become infinitely larger than the top if the number approaches infinity. Okay, so if you think about it like this, if you just do infinity divided by infinity square, you cancel out one infinity, you still have one infinity. That's still an infinite amount, right? Even though the top is infinite, the bottom you have infinite square. So what is this number? What would this number look like? 1 divided by a huge number. That would be 0, all right? So this is what I'm trying to say. If you have xy, if x you put in even like 10,000 or something, and in the bottom you have 10,000 to the 4th power, which is 14 zeros. And then at the top you will only have 8 zeros. Sorry, did I say 14 zeros? Yes, 14 zeros. And this one will be 8 zeros. If you plug in a number, a larger positive number like 6 zeros, at the top you will have 1 million to the square. It will be 3 times 1 with 12 zeros. But at the bottom, you will have 5 times 1 with 24 zeros. So you can see that how that number is just, this number is big, this number is so much bigger. So y would be 0. Because at that point, this doesn't even matter. It doesn't even matter. So what I'm trying to tell you is that take a look at the highest degree. Okay, when that is done, you will find that this number is 0. If you plug in negative number, right, negative 1 million or whatever, okay, this number is still going to be infinitely larger. But you need to take a look at the signs though. So this time is going to be a number that is it's like 3 with a bunch of zeros. And this one is 5 times a bunch of zeros, like with so much more zeros. So that's going to be towards 0. So now this one, it has a horizontal asymptote of 0. That's what I'm trying to get at. Y equals to 0. Okay. Now, this time, take a look at this number. This time slightly different. If you follow the same rules, you'll be fine. If you plug in a number like 0, you will get 0. If you plug in 2, you will get 4, 12, you get 4. If you plug in 1,000, okay, take a look at what you will get. You have 3, 1, 2, 3, 1, 2, 3, divided by 1, 2, 3, 0, like this. And then if you plug in a negative version of it, you would just get like negative 999. Okay, you will get, so this time it doesn't matter what number you put in. You can see that these two are different. These two, this one is the same number, and this one is 0. That this number changes based on whatever this number that you put in. This does not approach a number. If you plug in a different number, like for example, 10. That's not too 10. Let's just do a bigger number than before. It's easier to think about it. 1, 2, 3, 4, 5, 6. Okay, you will get 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over 1, 2, 3, 4, 4, 5, 1. Okay, this number got bigger when this number got bigger. So what I'm trying to tell you is that this one does not have a horizontal asymptote. It will approach because when x gets bigger, y gets bigger. Okay, so all right, now I want to summarize everything that we've been talking about by looking at the highest degree. If you look at the highest degree of this one is 1 over 1, the horizontal asymptote will approach the coefficient of the highest degree, which is 3 over 1, so that's 3. If you take a look at the coefficient of the highest degree, this is second degree, this is fourth degree. See, this one is the same, right? When it's the same, just do the coefficient. But if the bottom one is bigger, I just explained it earlier, how the bottom number will be so much bigger, or so much more negative, or so much more positive. It will going to be towards 0. It's kind of like 1,000 over 1,000,000,000, which is going to be almost 0. So when the degree at the bottom is higher than the top, it will be 0, always 0. Now, if the degree at the top is higher than the bottom, this is 2, this is 1, there will be no horizontal asymptote. Okay, we'll go back to class and then we'll put it all together. I know that this is a lot of information, but this is the chapter. Okay, and then we'll put vertical and horizontal asymptote together and then start graphing some stuff.